All right, so this is my problem 15 for the week 5 video explainers. So in this problem, there's a spaceship that's initially at rest, and then it's having its thrusters providing a force for it to move. And then the thrusters activate for 20 seconds, and then it coasts for 12 kilometers. So we're trying to find how long it took for the spaceship to coast this distance. So one thing that helps kind of visualize the problem is having this graph on the right side, and basically it's broken up into 2 time intervals, one time when it's coasting and then one time when the thrusters are activated. So if we take Newton's second law, we get the force equals mass times acceleration. So we are given the force, which is 1200 kilonewtons, which then turns out to be 1200 times 10 to the third newtons, just quick conversion, and then the mass of the ship in kilograms. So once we plug that into the equation, we get the acceleration is 15 meters per second squared. So now that we have this acceleration, we can use this displacement equation to find the total displacement or the distance traveled during the time of the thrusters. So we're going to get, so that distance is going to be equal to the initial velocity times time plus 1/2 acceleration times time squared. So it was mentioned earlier that the spaceship is at rest in deep space, so the initial velocity is going to be 0, so that takes out that term. And now the acceleration is just plugged back into there, so it's going to be 15 meters per second squared. So it's going to be 15 over 2 times the time squared, and it was going for 20 seconds. So that distance covered is going to be 3 kilometers or 3,000 meters. So one thing that we can solve for is the speed once the thrusters have ended. So as we noted earlier, the initial velocity was 0. So that final velocity at the end of the thrusters is going to be the acceleration, 15 meters per second squared, times the time, which was 20 seconds. So that velocity is going to be 300 meters per second. So we can use just a basic velocity equation, velocity equals distance over time, to find that we're going to try to find the time that it took to cover that second interval. So that's going to be the velocity, which was 300 meters per second. We got that from the previous motion equation. And that distance covered, which was going to be, so to find that total distance, so it coasted for 12 kilometers, and they were both, so that was 12 kilometers, and we found that other distance that it covered, which was 3 kilometers. So the total distance over that interval was going to be 9 kilometers, and then it's converted in that equation, which turns out to be, I believe it's 9,000. So then that time that it took to cover that interval is going to be 30 seconds. So that would be the time it took to coast that distance. So, and then just to find the total time, I guess, if you want to find that, would be the 20 seconds it was initially going for plus the 30 seconds that it coasted for. So a couple tricky things in this problem is just finding out which time or which distance corresponds to which interval, and that goes when you use that graph. It really helps out. And yeah, that was just the main tricky thing, knowing which equation of motion to use, kind of going through those and just seeing which one works best. And how this ties in is that once we get the acceleration from the force and mass we were given, something that we learned this week, we can then plug it into stuff that we have been learning in the past, like different equations of motion, and now we can have a little more, I guess, just complex problems that we can solve. So yeah.